This is a video that's going to go through the Lions and Cheetahs work requirement that you guys are going to be working on this week. So you might remember that we did some marble slides at the end of last term where we had these different graphs and we had to try and get the marbles to slide and pick up all the stars. Wasn't that fun? Okay, well, some of the stuff that we did in that was learning about how changing different numbers affected how exponential graphs look. This assignment is about sketching exponential graphs. So instead of a concept test on exponential graphs, you guys have this assignment. So the work requirement, you'll find this on Classroom. If you go to Classroom, and if you go to your classroom page, I'll do 10.2, and we go to classwork, then you're going to find underneath here video lessons, where this is. We've got online tools and help on how to submit work and so on. Have a look at that when you have to submit something, but you'll also notice that we have got this Lions and Cheetahs work requirement. So if you click on there, you can find this assignment. Okay, so the first part of the assignment is pretty straightforward. You need to define each one of these different terms. So Google will be your friend there. Don't forget to make sure that you put the mathematical definition. Okay, I don't want to hear that power is what Power Rangers use or something like that. It's to do with, of course, indices. Part B is the meat and potatoes of this assignment. So we've got a bunch of different equations that are all exponential equations, like this one up here. This exponential equation is a model. So how the numbers behave in this equation models what happens in real life. In this case, the number of lions is modelled by this equation that depends on the time, the number of years that go by. So as the years go by, the number of lions changes. There's a second equation, which is modelling the number of cheetahs in this park. In part C, we've got another model. This is N. This is the number of bacteria that are making an animal sick. T is the number of days this time. And then in part D, we've got a cure. So the number of bacteria, D, and we've got a T. And this one's got an extra one, it's N0. Okay, the number of bacteria when the drug gets added. So there's 4 different models there. All of them are exponential equations, and all of them have got a few things in common. They've got a number at the front without an exponent on it, no power, just a 20 times. It's multiplying an exponential part of it. The exponential has got a base number, 10, and it's got this variable up in the power, in the exponent. And most of them also have this number multiplying that variable. So changing these 3 numbers, the 20, the 10, and the 0.1, all make changes to the graph. If you want to get your head around how that works, put it into your CAS calculator and start messing around with the numbers. So if you jump on a CAS calculator and you open up a graph page, like so. Oh, I use Scratchpad. Never use Scratchpad. Open a graph page. Alright, on a graph page I could type in something like 20 times 10 to the power of 0.1. And I won't put t, I'll put x. And I need to put the times as well. When I press enter, I get a graph like this over here. Don't forget, if the graph isn't where you want it, you can't see what you want, you can double click here and change the number. I'm not really interested in negative years, they don't make sense in this problem. So I might just change that so that we're only seeing a part of the graph that we want to see. So now I've got my graph. What happens if I change some of this? If I hit my tab button and my up arrow, what's going to happen if I change that 20 to 30? What happens if I change it to a 5? Interesting. What about if I change this number 10, the base? What happens if I change that 0.1? So you can have a bit of a mess around and try and get your head around what those different numbers do to the graph before you start the assignment. And that's going to give you a pretty good start on the assignment, because ultimately looking at how those numbers affect exponential graphs is one of the things that we're trying to teach you in this graph, in this assignment I should say. Alright, the questions are fairly straightforward. Showing or working, find the number of lines when counting first began. Don't forget to write your answer in a sentence. So what it's talking about there is to figure out, when does counting first begin? How many years have passed when we first begin counting? Trick question. So no time has passed when we first begin counting. 0. So what is 0? It's the number of years since counting started, t. So to figure out this first answer, what we're going to have to do is figure out what this equation's value is when the t has a value of 0. We just need to substitute 0 in place of t and then do it on our CAS calculator, find the answer. The answer, of course, will tell us how many lions were in the wildlife park when we started. Question 2 asks you to do the same thing for this other equation, the cheetahs. Don't forget to write your answer in a sentence. At the start of counting, there were 247 cheetahs, or whatever. Okay, the next question is similar. This is where t equals 1 and t equals something. Don't forget, t is the number of years that have gone by, and this number is not in years, so you're going to have to convert it into years to get the answer to that. But again, you have to substitute a number in place of t and find the answer. Just doing it on CAS, but don't forget to show all your steps in the working. Don't forget to write your answer in a sentence. Question 4 asks you to keep doing that. You can transfer your answer from question 1 into this spot here. This is the number of years, number of lines. For question 1, we did that over here. Number of lines after a year, number of lines after 2 years, 3 years, 4 years. So you're just putting in t equals 0, 1, 2, 3, 4, 5. I would like you to do that to at least 2 decimal places, please. When you stop it after 2 decimal places, you should be rounding the number, not just lopping the numbers off the end. Alright, the next bit is to plot these values on a Cartesian plane using graph paper. Okay, verify it on your CAS. So I've showed you how you can draw it on your CAS, but you need to plot it on graph paper. Please note that I expect this graph to fill up the whole page, and I expect the graph to be accurately plotted. It should have a title on it. It should have the axes with labels on them and units. If we look ahead a little bit, it asks you to find out some other things using your graph. Where does the two graphs intersect? It asks you to find out when it reaches a population of 40, and so on. So it would be good, before you go ahead and do your good copy of that, to make sure that your axes are big enough to cover the answers to those questions as well, so you don't have to do it twice. Okay, so that's all I'll say for now. I'll go through the other parts of this assignment in another video lesson.